Okay, so we are right on time, and thank you for organizing this track. Thank you for the opportunity to speak to you. This is Marcel, my name is Markus. We are both research associates at the Department of Medical Informatics in the city of Göttingen in Germany. And now we switch from the neurosciences domain to the medical research domain. And our plan is to give you a very quick overview of some of the tools that we use in our domain of research, and just to get an overview, who has ever been in contact with the domain of medical informatics? Quite a few. Oh, well, it's overwhelming actually. So you might recognize some of the tools, but for all the others, we try to introduce a little bit the discipline in general. So we thought of how to characterize our domain, and we said there's like 4 major fields of research in medical informatics. So at the core of it, there's systems for primary care. So I think everybody can relate to that. When you are sick, when you go to the hospital, your case creates data, your condition is documented, and all of this is done in electronic health record systems. Maybe there are images taken, MRI, CT, echocardiography. Those are put into some information systems, and all of this is primary care domain. And then we have a couple of research domains, or research-heavy domains. First of all, biomedical research, where you study the system's biology within the body and derive therapy ideas. The other route would be to go down here into take routine data, run statistics on them, and do use, so it's called secondary use, because data that was collected in primary care is used for research to develop new therapy options again. And finally, because we run something called evidence-based medicine, we want statistical scientific evidence that the therapies we run in primary care are actually not harmful and even beneficial for your condition. So all of this goes up to the top into what's called clinical trials. So basically you do experiments in human to make sure that everything we do in therapy is actually sound. We will go through a couple of software tools that are part of some of those fields. And one thing I would like to mention is that the primary care is basically probably the domain with the least open source software, which is due to the regulations that are in place in primary care. I mean, you're treating patients, which means that even software will soon have to comply to European medical device regulations and so on. So many companies create proprietary software and sell it because they say our software complies with all the regulation. So to take you through the software tools that we want to introduce, short story. This is Bob. Bob suffers from chronic heart insufficiency. So this means that Bob regularly has to visit the hospital, have his condition checked up. Every time he has to go in for a routine checkup, they document the medication he's on, they take blood samples, and also they make echocardiographic imaging. And all of this is stored in the clinical information systems. So this is a model hospital because they actually use an open source tool for primary care documentation. In this case, they use XNAT, which is a picture archiving and documentation system that is open source. And that can store the images created and the structured data that is derived from those images, so the vital parameters that are actually interesting in further research on the data. XNet is a very extensible open source tool. You can not only store the images and share them with your colleagues, you can also plug in analysis pipelines like ImageJ to run analysis on the images and data that is stored in there. And yeah, in the end, it gives you web-based user interfaces for image upload, also image viewers, etc. So since Bob is also not only at the model hospital, but he's a model patient, he has given consent for that his medical data may be used for research purposes, just like that. And this leads us to, of course, Alice. And Alice is a health data engineer at a place called the Medical Data Integration Center. So that's basically where we work. And her job is to get all the data that is created and documented in primary care systems out of those systems. So you extract this data to mask patient identity, because in clinical systems you always have the medical data stored for each patient, and you know who this patient is. In research, we do not want to know who the patient is. So we want to anonymize the data. So the data has to be masked. Then the data has to be transformed according to the formats that you can use in research, and finally put into some kind of research data repository to make it accessible again for researchers. The tool that Alice uses is open source, and it's Talent Open Studio for data integration. So this is a graphical user interface data workflow manager. I'll give you a little bit better image of that. So you can create data transformation workflows with a graphical user interface. It's based on Eclipse. It's also provided as a product by a company, but all in all, it's open source tool, and you can create these kind of workflows, dragging and dropping like sub-processes that are encapsulated and can be reused in different workflows. You can export all of that as a jar file and then run it on servers and orchestrate this. And this is basically what we do to extract data from all the different clinical information systems and put it into a single research repository in the end. So sub-processes, part of these ETL jobs run through Talent, is for one, the masking of the patient identity. The example tool we use for that is the Mainzelliste. It's a German name for a tool mostly created in Germany. So please excuse me that these slides are in German. It just says that we pseudonymize the identifying data of a patient. So you see the name on the left actually, and then you pseudonymize it. You just get some random ID number back, and you can also use this service, this masking service, to create different secondary IDs that belong to this first ID. So yeah, there's lots of math behind that, and you can actually do lots of stuff. So you can do de-identified record linkage. So you have research data from two different systems that have separate IDs. You do not know that those are the same data from the same patient, but you can use the service to link those data back again in the end. Yeah, so each of those de-identified data packages that we now created in the first step of our workflow has to be stored. And we are working in science. We want to have all the data pieces we use in the scientific progress archived and stored persistently. For this, we use an open source tool called CD-Star. This is developed in Göttingen. It's a data storage middleware, basically. So we mask all the underlying block storage options or that are run in the data center. We put a REST API in front of it, and we can just use REST calls to store data items together with access control lists and metadata about this item. And we also generate persistent identifiers so that each data package that was used in one of those processes can be identified afterwards permanently, hopefully forever, because we use a data center that's in the forever business because they are linked to our university library. So this is the queue to switch.
So awkwardly switching has been done. I hope the cartoon was long enough to distract all of you. So we've seen that Alice has stored her data in CD star, and now she has this data in some format she maybe thought of. But we would like to have more. We would like to have semantic annotation, meaning that the data file itself should contain something that tells some other person what the data is about. So you may know it from CSV files where it's just data tables where you don't know what it means, and most of the time a table header that says some weird combination of letters that you don't understand. So in order to circumvent that, we use OpenEHR. OpenEHR actually is a foundation, so it creates a lot of stuff, but the two things we want to focus on would be the specification as well as the clinical modeling part of OpenEHR. So as for the specification, the guys at OpenEHR created a two-level modeling architecture, where the specification states different reference models. These are the most basic parts that you can store data in. So think about it as data types in every programming language, like character or integer or something like that. Using this reference model, you can go a level higher and use it in the, let's say, user space, where different users with clinical knowledge can take this reference model piece of information and put them together into an archetype. An archetype would be a, let's say, logical compounded value that you can store in a database afterwards. So meaning that instead of just storing a number, you want to have the blood pressure, you need two numbers and maybe some other units or something like that. So an archetype would, for example, be Bob's blood pressure. At the topmost level, the templates are even a higher level collection of archetypes, meaning that you can model even higher level constructs like a visit. So meaning that a patient comes to a hospital, you are able to create how should a visit look like, what archetypes, what parameters has a study nurse to record in order to map everything to a common data format. If you do that, a template may look like that, so pretty complex, pretty big, and it's more or less really hard to just look at the data itself. So imagine that will be a really big JSON or XML file. It's hard to find the data in that. So obviously the guys of OpenEHR thought of that and created the archetype query language, which is a kind of hybrid between SQL and XPath that allows you to traverse the hierarchical data and get your data that you want to have out of that. So very nice. We have now the data in a common format that can be understood by other people. So let's introduce another researcher called Carmen. And she wants to get the data. First of all, she does research on heart insufficiency. So just the condition that Bob has. And she now wants to have some data from the OpenEHR repository. So if she's capable of doing that, she will specify some kind of AQL query, get the data out of the database that is set up at the hospital, and is then able to use another platform or another tool to analyze the data that is called I2B2 Transmart. Again, I2B2 Transmart actually are two tools, but they are being merged right now together. And this tool is a clinical data warehouse that allows to do some simple analytics and analytics on data. We will focus on Transmart for this presentation because it's the tool that we run at the moment, but in due time we will switch to the I2B2 Transmart merged tool. For that, you can see, in this picture, you can see how this can look like. So you can look at very basic statistics like the distribution of the age or the gender distribution. So to get a feel for your data that you have. And you can even run more sophisticated analysis using R scripts. You can just create an R script, write it, upload it there, and the analytics engine will give you the output that you desired. We use this tool primarily to kind of do a data review. So in this example, you can see that there is a correlation between age and height. You can see that there is a lot of data points on the left, but only one at the right. This is because the person that is depicted there has a height of 165 meters, which is, let's say, unlikely, but it just shows that data that you integrate from heterogeneous IT infrastructures usually are erroneous, and you have to think about that, and you have to keep that in mind. Okay, so let's say she had a research hypothesis. Carmen that specified that, did her research and was able to either approve or reject the hypothesis. She writes up a paper, and everything is nice, everything is clean, and she submits this paper to an open access journal. What we'd like to see is that she opens up her data as well. So in the spirit of open research, open data, she should publish the data somewhere. She could do that in a FOSDEM-seq instance located at the hospital, run at the hospital. FOSDEM-seq is basically a data repository which follows the ISA standard, which stands for Investigation, Study, and Assay. Thank you. Most importantly, it stores rich metadata with the data files that you can upload there. So you can assign a license, you can say this piece of data was conducted in this study using this investigation and so on. And with that, you can much better publish the data and store it persistently. So even after several years, you can provide the same link. You can call that link and you can see, okay, this data was used in this publication, and I can maybe open up this publication to find more about the data or vice versa. So thanks to all the tools and the people that are involved and that were able to use these tools, maybe Bob can get healthy and all his fellow patients can lead longer and happier lives. So for one hospital, this may even be somewhere the case, I don't know, not in Germany most certainly, but what about sharing data with other hospitals? This is something that is very hard to do for us, especially. We're working on that project right now, and we can see that there is a lot of data infrastructure on the global level that tries to do that, to link data together, so create this internet of data objects. There is a lot of work put into that in different domains, and for example, in the medical informatics domain, on a national scale, we have the Medical Informatics Initiative, which has offered us some money basically to build this up for Germany. On the international scale, Odyssey or Eden do basically the same with other data formats, other technologies, but have the same goal. So it's a very, very good movement to see that they want to link the data together. And cross-domain, there are also developments that most of you people may know, like the Research Data Alliance or the working group from the W3C Data on the Web, which has specified the DOAP protocol to access digital objects from different domains or from different IT infrastructures. So in order to use this data over the boundaries of our hospital, we have to think, especially in medicine, about the security. Medical data is very sensitive. As we said, we are doing masking of the patient data, but still that's maybe not enough. If you think of rare diseases, it's very likely that a doctor that knows a lot of rare diseases or works in the field is able to find a specific combination of some diseases and know, okay, I know this patient. I've seen that before because it's rare. So this medical data bears both high value for the research, but also potential for misuse. So we think that the benefit from linked medical data has to be exploited, basically. So we want to have the data, we want to have it accessible, and do research on that to improve healthcare. But what we need to do would be to create secure IT infrastructures for that. So not everybody should be able to, just like that, download everything and have it in a really big, nice repository and do some, I don't know, big data analytics or something like that as he wishes. But we do need some regulation and do need some safeguards in place. And to do so, we need accountable and transparent workflows. So not only we have to make it secure, but the patient should know, where is my data going, what is happening with my data, where is research maybe published with my data, in order to empower the patient. Scandals like the Cambridge Analytica data leak or the leak, what they did with the data doesn't really make it particularly easy to say, go up to a patient and say, hey, can we have your data? We want to do research. So they're pretty hesitant on that. This not only counts for the data, but obviously for the tools that we use themselves. So we try to use tools that are off the shelf, are available for download, but not every tool fits our purpose. So we have sometimes to extend it or even build new tools. And from our perspective, this has to be open source tools, because this is the only way to really get transparency and empower the patient. So things like public domain, public money, public code show that we're going in the right direction and have a political, let's say, a layer to talk about these things. So we need that for medical research especially, and we should emphasize that everyone who's working in this medical field should think about that making not only the data open, just as is, but thinking about the tools that you are using and making these open, and the data flows you're creating. So global data infrastructure, we saw them, they are being built, and we should establish decentralized and free technologies to ensure secure IT infrastructures. Typically, the medical information systems are really not free or open source whatsoever. These are proprietary big blocks that we saw that are very black and nobody touches them. But the tools in medical informatics research are frequently used and could be very well rolled out to more of the primary care. But we have to advance that. We have to politically like make a voice for that and say, hey, there are tools you could use. And yeah, please do so if you are capable. So we saw that some people from the medical domain here raise your voice. It would be really a step forward to have more openness in the medical informatics research. So for the references, obviously thanks for the team in Göttingen. We had a lot of guys that are very open to the whole open source community, and we try to advise it on further use. And like everyone basically said, if you're interested, contact us, we have jobs. Yeah. So thank you very much. Questions doesn't work if I turn off the microphone. So any questions? Yes.
Actually, I don't find this, that the software is appropriate, and I find that, for example, this format of medical research should be open. The exchange format should be open, or let's say unified somehow. The first one. And second one, what we do, it's for still it's for the human, for the doctor, or it's somehow system to get such a system which treats the person, or let's say helps the doctor to treat, or I don't know, with some kind of algorithms.
So the first comment was that we do not necessarily need open resource tool or research tools, but especially open formats and open standards, right? So like OpenEHR, we presented it. There are a lot of other standards, FHIR, OMOP, CDM. We agree totally. So we do need that to exchange data and enrich it semantically, so others can reuse the same data. The second comment was the question was where is our field of application, right? Where we going with that? So basically, as medical informaticists, we're kind of in between everything. So basically, we're trying to help the researchers get the data, analyze it, and derive research hypotheses from it. We're trying to get to the patient to empower his view on his data, and we're also trying to go a little bit into primary care and say, hey, look at that. We have these tools. We use this path to get the data from A to B, and wouldn't it be a possibility for you guys in the IT? Yes?
You talked about sharing data between medical institutions as well as like a political movement to get this underway, which happens to be exactly what we're trying to do in the Netherlands. So my question is, how can we get in touch?
Okay, the question was, there are similar movements in the Netherlands right now. So basically what we shouted out, we want to have doing that in the Netherlands, so great. Please come to us after the talk, we would like to talk, I guess. And I think, I don't know which project you are associated with. There are some projects that do that internationally, but I agree, there's not much communication, so everybody gets this grant and tries to build up something open sourcey, and then we have 60 different versions of open source standards which comply very, very badly. Yeah, so I guess, yeah, the answer is let's talk. We have to talk.
I'll come and find you after.
Yeah, sure.
Hi, thanks for your nice talk. I just had a specific question are in one consortium, but is there a lot of dialogue with the other consortia? Because I get the impression they are also developing different versions to do this. Is there a lot of discussion on using open source tools there as well? Or
So your question was regarding the medical informatics initiative in Germany and how the 4 consortia that are being funded there act together. So
especially relating to this.
yes, especially relating to the open source tools. So we have organization that goes above all of it and tries to increase the communication between. But of course, these are professors talking about problems that have to be solved. On a working level, we try to establish those. I mean, in Germany, it's not a huge community, so basically everyone knows everyone somehow, and we have meetups and so things like that. So we have to increase the talking bit in between. We try to do so, and we try to establish. Well, let's say the standard for open source is set. I've never seen a researcher in medical informatics who says, nah, open source, we don't need that. Everyone is the same. But what we have to do is to deliver that more into primary care and to the people that are not affiliated with medical informatics itself, but maybe more in the medical IT, which are somewhat more hesitant regarding that.
Okay, thank you. We have to cut now. You can speak with the speakers afterwards.